I do want to welcome everyone. This is our second series of webinars. So we are now much more experienced with our webinar software, which is nice. And we're really excited. After our first series was really on testing in general, which is a great topic, we wanted to go deep into unit testing and really sort of start from the beginning with it and go through getting set up with unit testing and getting set up specifically for unit testing with Alexa. So we think it's a great topic, and we're going to go through some stuff that I think is pretty basic and is probably familiar to a lot of people, and then try to get to some of the good stuff as we work through the whole webinar. Before I jump into any slides or the presentation itself, just a few notes. One, we'll be capturing everything from this presentation, and so you'll be able to get this on our website as a recording later on. So if for some reason you have to drop off or you want to share it with somebody else, know that it'll be available afterwards, which we think is really neat. This is meant to be interactive, so please do put questions. There's actually a specific question section. You can put them in there. People put them in the chat window too. We're not going to get upset if you do that. And I will try to respond to them. I also have my phone with me, so if I'm looking at my screen, I kind of bounce over and look at my phone. And the team that's with me will also prompt me if there's a question that I'm missing. And then lastly, I'll just note there's a poll section that's available, and we'd really love to hear your responses to those polls. It's just helpful information for us about where people are in their testing practices. So with that introduction, I am going to jump in and share my screen here. And we are going to do this one a little bit differently than the first time, in that we're going to keep the video going simultaneously. So sharing my screen, and I am going to present these slides. Great. So as I mentioned, the topic for today's webinar is unit testing Alexa skills. What we're going to go through, we're going to have some introductions. Then we're going to do an overview of unit testing in general and why we think it's important. We're going to walk through getting started with Mocha and Chai, which are two of the fundamental unit testing tools for JavaScript. Then we're going to get into the virtual Alexa component, which is something that we provide, which is an emulator that really helps with testing Alexa skills. And then we're going to go through implementing code coverage and setting up continuous integration. And then lastly, we're going to leave some time at the end for questions. So just to introduce us, I'm John Kelvie. I'm the founder of Bespoken. And I'm joined also, you'll see Bo Schrader, who's our head of marketing, and Yvonne Perez, who's our customer success lead. They're also in the chat window there. And Bespoken, what we do, we provide monitoring and testing tools for voice apps. We're a recognized vendor of Amazon and Google. And we have over 800 apps currently being monitored. We have more than 1,500 developers using our platform, which we're really excited about. And we also just have a long history with speech recognition AI that even predates Bespoken. We've got a lot of experience around scaling and testing AI and speech recognition based apps. And that really informs a lot of our perspective on this, as well as how we build our products and how we approach this market. So that's a little bit of background on us. And then what do we want you to come away with from this presentation? One, an awareness of the unit testing tools that are out there. I think not everybody knows how robust the capabilities are for unit testing with Alexa. We want you to have a great template for a unit test enabled Alexa project. And so the basis we're going to be working off of is actually a nice project you can use yourself. And then we want you to have a step-by-step roadmap for how to implement unit tests. And so you'll see that as we go through. And then lastly, we want you to have an overview of, yeah.
So it's not very good.
Hopefully you guys can still hear me there. We want you to have an overview of advanced use cases and where to go next.
Half a cup is fine. I don't want too many beans. I want more vegetables. Oh, and then I might have to make a vegetable stock too. So just whatever we have in the fridge.
Sorry, that's background noise where I am.
I have carrots coming.
I'm just going to pause for 1 second. Sorry about that, guys. Just had some background noise here. Hopefully you guys can hear me better now. So why do we do unit testing? This slide you probably saw from our last presentation if you joined for it. It's really helpful for identifying bugs while you're developing. It facilitates code coverage, and it's really about testing without dependencies. So you're really focused on being able to test your code and ensure that it's high quality in isolation from other pieces. And so that's really a critical part of it. If you came for our last webinar, you heard us talk a lot about end-to-end testing, and unit testing versus end-to-end testing. You really have very different goals. In one case, you're testing just the code, and in the other case, you're trying to test all the pieces, including things like speech recognition and complex dependencies that you might have downstream. Those are both very important pieces. We're just focused on the unit testing today. We'll probably do another webinar, and we'll go into more detail on the other pieces in a future one. And so I also just want to make a quick pitch for why you want to do this stuff right from the outset. So there's a long-term ROI to testing, to having high-quality scales, and that's about if you identify bugs early in the process, say during the design stage or implementation, versus when you get into a bug that's actually out in production. According to this study here, which I believe came from Microsoft, it's 2 orders of magnitude more expensive, a bug that's in production versus one that you catch during design. And that's because once a bug is out in the wild, you have so many more things that are involved in fixing it. You have deployment processes, you have QA teams, you have the development processes that need to go through, need to be gone through in the different stages. And then just also the wild goose chases that happen with the production bugs. And so I think everyone knows this, and we know that there's a great expense to production bugs. And so, we know there's that long-term ROI. What not everybody knows about is the short-term ROI. The short-term ROI is the fact that you're actually going to save yourself time right now if you start doing unit testing. You can actually get your work done faster. And I know that can be a little counterintuitive. A lot of people do say, well, I do want to get this unit testing. I want that long-term ROI, but I have this upcoming deadline. And our pitch is, look, you're going to meet that deadline. You're going to meet that faster if you actually invest in getting the unit testing set up. And so I just use this slide here, or this picture here from it's from Ratatouille, and I like the analogy to cooking, which is that if you have a nice, clean, well-organized workspace when you're cooking, you're going to actually not just create better food, but you're going to have you're going to be able to make your food faster. That's what they say in the movie Ratatouille. That's what I found in my own experience with cooking, and that's also what I found in my own experience with coding. And we'll try to show you some of the examples of that. But just in general, the idea that if you have a nice, clean, well-organized workspace for your code, you're going to do better. And then also just a quick overview of our architecture here. So we have our virtual Alexa component. That's what we're really going to spend time on today. That's the emulator piece. And that's not actually using Alexa. That's just generating JSON as if it's coming from Alexa. And so that works in isolation. But we also have our virtual device SDK. We went through this a little bit last time. That's our end-to-end testing piece. And the virtual device SDK is actually going to interact with the Alexa voice service. So it's going to generate audio, send it to the Alexa voice service. In turn, that's going to send it to your skill. That's going to get back a reply. And it's going to send it back to the to your virtual device SDK. In turn be translated into text, which you can then do for comparisons. So two very different pieces, with those two pieces, you can really really cover everything that you need from a testing perspective. But again, today we're focused on that virtual Alexa piece. So with that, we want to go through a walkthrough on how this works. So first off, getting started with Mocha and Chai, or Mocha and Chai, I should say. These are the most popular JavaScript unit testing pieces. There's actually many that are out there. Jest is another popular one that we happen to like a lot. But there's several ones that you can pick from. We're showing Mocha and Chai because it is the most popular. And we think they're very nice tools. Mocha is really the testing framework and for executing the tests. Chai is an assertion framework, and so it's for doing the comparisons within a test. And with that, I'm going to go to our project here. And what we have, this is a really simple project. And so this is probably a little small. Hopefully you guys can see this okay. Let me zoom in a little bit. How do I enlarge the screen here? Oops, changing projects. All right, well, hopefully you guys can see this okay. This project here is just a hello world skill. And the hello world skill, it takes an intent, and all it does is it says back, hello world. Really, really simple. And we have not actually set up any tests for this. So this is completely greenfield. This is a working skill, but we want to add some unit tests. And so we have this empty file. So in my project, install Mocha. I'm going to do npm install Mocha save dev. And then I'm going to install Chai. And now I've got those two pieces set up. And then to set up my first initial tests, and I'll show you guys just, if you want to cheat, you can kind of jump ahead because I have all these different steps set up as branches here. So I can take this basic test, and I'm just going to cut and paste it in here. And these are not anything specific to Alexa. What we're really doing here is we're just showing how to use Mocha and Chai. So two really, really simple tests. And I need to add just one more piece here. And it's to say, add this command test. And now these two tests, one, I'm just doing a basic expectation. And in this case, I'm using this expect syntax. So this is a nice thing with Chai. It supports both behavior-driven development as well as test-driven development. The expect syntax is the behavior-driven development nomenclature. And I would encourage you guys to read more about this. They're both interesting development philosophies. They sort of build upon each other. Behavior-driven development is really focused on writing things or creating tests and code in a very plain English way that's focused on use cases. And in turn, test-driven development is about really starting your development from your tests and building your code around that. And so you'd start with a bunch of tests that are not passing, and then you'd add the code steadily until it does pass. We're not adherents to a particular philosophy, but we think that these are both useful, and we would certainly encourage you to check them out. And it is worth noting, we're using this BDD, behavior-driven style test syntax. And if I go ahead here, set this up and I say NPM Test, and not surprisingly, these pass no problem. And these tests are really simple in that they're just, one is a true and one is then running asynchronously. And in that case, we have this done parameter that gets passed to the test function. And so in this case, the asynchronous part is we say set timeout. And then it calls done. So that's a really simple test that's just using Mocha and Chai. Now let's get into actually doing something with Alexa. And with that, so now I want to install our virtual Alexa component. And Jonathan, I do see a question from you there. This is really just to illustrate getting these pieces set up. I mean, these are not meaningful tests. We're going to get into some more meaningful tests right now. This is just to familiarize everyone with Mocha and Chai and how they're working. So if we want to create now a test for our launch request,
more to do with the.
So this is a really simple test also, but this is actually going to exercise our Alexa skill. And so what it's going to do is it's going to say alexa.launch. It returns a promise, so we have the then. And then the result that comes back is the JSON that comes back from our Alexa skill. And so then we can perform whatever test we want against that JSON that comes back from our Alexa skill. And then at the end, because since this is using a promise, it is asynchronous, we then call done inside here. If we don't include that done, the test will fail. Now, before we can run this, we do need to set up our virtual Alexa piece. And there's really two important things for that. Oh, I'm also forgetting. So one, we need to import our module, virtual Alexa here. Two, we're going to go ahead and set it up, and we need to let it know where our Lambda is. So in this case, we say our Lambda's source index, and then the dot notation points to the actual function, which is here, handler. And then we tell it where our interaction model file is. And so we're using the ask CLI structure. And so it's under models, ENUS. There's our whole interaction model. We support several different structures for that interaction model. And then we just call create on it. And we're using this before each. What this does is it gets called before each test is run, as the name would suggest. And so we have this launch example, and we can actually go ahead and we can say NPM test on that. And boom, now our launch is being run. And if you're curious to see what that payload looks like that's coming across, you can put in a statement like this, and we'll be able to see the JSON that's being sent. And so here's that JSON that's being received by our skill. So pretty neat stuff, hopefully straightforward. Now that we've tested our launch command, we can go ahead and write a test that's going to actually do an utterance. And so in this case, we're saying alexa.utter hello, and that does line up with our samples here. And then based on that, again, we're going to get back the response, hello world. So we add that in. We can run NPM test. And perfect. We'll see here that that utterance gets turned into an intent request, an intent name hello world intent. And then in turn, we get this response that includes hello world. And one thing that is really neat about this, and I think to the point I was making about how writing unit tests can really save you time, is with this, you can actually just jump in here and debug your skill. So I'm showing you guys WebStorm. And if I go ahead and I just say debug on this, just like that, I can set a breakpoint and I can inspect this result. And so I can see everything that's coming back. And so this is really super helpful when you're running into tricky issues, especially if you're running into something in which it's a multi-step process. Having this is really, really helpful. And another thing I would just highlight here, so if we go back to this example, we can set these filters, which are really quite powerful. So I can set a filter, and if I want to modify things about the request before it gets sent to my skill, I can go and add elements to it. So if I want to set the display capability or video app capability, or really do anything to that request to set up particular test cases, it's very easy to do. And I just go ahead, modify the JSON in whatever way I want. And you know, set up that test. And it's really helpful. And you can see this one here, so I can run this guy. So you can see that incoming request, and you can manipulate it as necessary. So that's really helpful, again, for sculpting particular unit tests or getting to sort of edge cases. I'm sorry, I hope you guys can hear me okay. And so with that setup, the next thing that I want to show you guys is how to then integrate this into a code coverage tool. So I'm going to show you what the output looks like with code coverage. So we have this all set up, and we use something like codecov.io. We have these nice graphs. We have this breakdown within the skill or within the code itself. We can see how well tested everything is. So how do we get this set up? So in this case, we're relying on two pieces. One is a thing called NYC, which is from the Istanbul project, interestingly enough. So we install that. And then we want to install codecov. So we have those two pieces set up. And now configuring them in our project, it's pretty straightforward here. One, we simply add NYC in front of our call to Mocha. And so that's going to cause our unit test to generate code coverage information. And then we add this post-test part, which is going to cause reports to be generated, as well as send data to CodeCov. And then the one other piece you want to add here, there's lots of settings for NYC, and you just include them in your package.json. Here, we're just going to set up a couple reports. We're setting up a JSON report as well as an HTML report. The HTML report is for us to look at. The JSON report is that's actually used by CodeCov. So the local HTML report is actually quite helpful as well. CodeCov is great though because it gives you the history over time on how your code coverage is evolving. So now that we have these pieces in place, and it's pretty simple, right? I can go ahead and I can say NPM Test. And I'm going to get an error running CodeCov locally, but that'll be easy to fix once we push this out to GitHub. But in running this, I now have this file that's generated. And I can see one, my level of coverage. Two, I can look and see where I have testing problems. And so based on this, I want to go ahead and add an additional test for this help intent. So now that we have all these pieces in place, this is actually really easy to do. We can actually go in here. So I can go ahead and say utter help. And I don't need this line here. And if I go back and I run this again, all my tests have passed. And now I can see that I have my code coverage on this intent as well. And so this process, where we only have two other intents, it's an exercise that's left, if there are people that are on this call, but to add additional coverage to include these additional intents is really straightforward and something that we would recommend. You don't always want to go for 100% code coverage. Better than 85 or 90% is usually a good goal. But in this case, a simple file like this, there's no reason not to test every intent. So it's pretty easy to move forward and add that as well. So now that we have that set up,
just hold the top two because it's two separate.
We have our code coverage. We want to actually tie this into our continuous integration. And at that point, we'll see how it goes into codecov.io. So setting up our continuous integration is really simple as well. So for that, Just create a file. I'm going to use Travis in this case. There's lots of good CI tools that are out there. And just take this piece, paste it right here. And then once we commit this, we're pretty much all set with Travis. The only thing we need to do oops. And so I already did this here, but if you just enable the project, so where's our project? Right here, I add that travis.yaml and I flip this switch, and now I have Travis running. And with it, so now what happens out here? So here's an example of a run. And it actually looks just like the output that we have on the command line. But in addition, because it's now in GitHub, CodeCov knows how to automatically tie off data coming from a project that's hosted on GitHub publicly. If you have a private project, you do need to add this token that's an environment variable to tie off your CodeCov to your source code in GitHub. But for public projects, it just does it automatically. If you do have to add that token, that's a really easy thing to do. You're just adding it as an environment variable within Travis. And so with that, we have really a fully automated project that does our unit tests, our code coverage, as well as our continuous integration. So really, a lot of neat stuff there. So before I go any further, this is sort of the essence of what we wanted to go through in this presentation. I just want to pause and just ask, questions on what we've gone through so far. What makes sense here, what doesn't, before we go into or touch upon some of the more advanced use cases. So I see Liz says, could you briefly tell us about your process? So yeah, our process, we use a combination of manual testing, unit testing, end-to-end testing, as well as ongoing testing through our monitoring features to ensure quality. And so this unit testing I'm showing you today is just really one component of it. It's a critical component, and so we use it to ensure that our code is high quality and well covered. And so, okay, do you write a function, then unit test? So that's a great question. I touched upon test-driven development. That says write your tests first. I'm personally not an adherent to one of those philosophies. I sometimes write my tests first, but typically I write the code first and then I write my tests afterwards. And yes, I am almost always in the editor and the CLI. I'm just flipping back and forth between the two of them. Probably more time in the IDE just because, so I was running NPM Test there. I know that's what a lot of developers prefer, but like WebStorm and other IDEs that are out there, you can also just do things like this. You can right-click on a file, and you can say run, and look, you get this. Oh, wait. I'm not sharing my screen. Sorry. Hi, guys. Really sorry about that. I moved to a quieter area here, I hope to. Yeah. Sorry, I live a slightly nomadic existence, so may not have had the best spot for this one today. But in terms of where we spend our time, what I was trying to show a moment ago and how we run this is I tend to spend more of the time in the IDE. And the reason why, which I'll just show you, is with something like WebStorm, and most IDEs have features similar to this, you can right-click on a test file as a whole and say run. And if you look down here, you get this great output. And you can do things like pick one particular test and rerun it. You can see the specific console output tied to any particular test. Just really lots of helpful stuff, as well as being able to go through all your breakpoints and all those sorts of things. So there's a ton of features you get with an IDE, and writing good unit tests allows you to take advantage of them, which I think is a really nice thing. So that is where I tend to spend more of my time when I'm doing development. Yeah, so I mean, changing states within your test when your skill has different states, that's a good segue to look at a more complex skill. So I know that most people are using state machines. That's certainly what's baked into the Node.js SDK. And you know, I'd like to just show you a skill that we have that also uses a state machine, and how some of those more complex tests will look in that case. So I'm going to share my screen again here. And this is actually one we went through last time. But so here, this is actually working through a whole sequence of interactions with the user. And it goes through different states within this game. And it's a game that's kind of similar to the Price is Right, where you're guessing prices for an item. But this goes through 2 or 3 different states, and you know, it's going to start off, you're opening it up, then it asks you how many players there are, it asks you to name the players, and then it asks you to guess what a price is. This is a pretty typical thing that you're going to have. And you know, if you have an issue, say in this 5th step, you know, as you move from, you know, a welcome state to a onboarding state where you're getting the names of the users into a playing state, if you have an issue in that playing state, this is actually going to allow you to quickly jump into that step and find out what's happening here. So if I open this in my IDE here, I can run this. Oh. Oh, I'm not running it. Sorry, I don't have this figured in my IDE, but if I had this set up in my IDE, I can just put my breakpoint here and I debug, and I can see what's happening in that step, which is really super helpful. Another thing I would highlight with this particular test, we're actually using Babel here. And by using Babel, we can take advantage of async await. It's pretty easy to set it up. And with async await, you're not using that promise structure. And it just gets, you know, it gets more readable. I think you can see here. It's really rather nice. It's a nice feature to take advantage of. And so then another sort of advanced use case that I'd want to touch upon is the audio player. So we have support for actually complex audio player behavior. And so here's a project we have called the Super Simple Audio Player. And it actually just plays through an array of podcasts. But it actually handles a lot of things underneath the cover. So we can say launch, and then next someone says play. And we make sure that the correct response comes back from that. And then we can say next. And at that point, we can make sure that we get back the the correct response there. So when somebody says next, we want to make sure that we get back an audio item with a stream URL that's episode 12. So we start off with episode 13, then it goes to episode 12. And then we can emulate receiving events from the audio player. So we can say, audio player, playback nearly finished. And for those of you that have developed with the audio player, you're probably familiar with the playback nearly finished request. That's really an important one, because that's what you're typically going to use for queuing up what's going to come next. And so when that playback nearly finished is called, we can then look at, we're expecting a directive to come back because we're going to queue our next track. And so we're going to see that the response has a play behavior of in queue, that the audio item that's being queued up is episode 11. But then at the same time, our emulator, and this is a really neat thing that probably deserves its own session, but it actually is going to maintain that state of the audio player as if it, was behaving like Alexa. And it's going to say, okay, I'm still playing episode 12. I know you've asked to enqueue episode 11, but until I receive that playback finished event, episode 12 is still going to be playing. And then once this playback finished is sent, then you're going to get this guy. The currently playing will be episode 11. So the one that we enqueued will start to play when playback is finished on the previous track. And so this behavior allows you to do very complex testing for the audio player and really thoroughly test audio player-based skills, which we think is a really awesome feature. There's a lot to go into with that. I'm not going to go through it all right now, but we have a number of examples out there about testing the audio player. It's definitely something that we've made a focus, and happy to follow up on that, and maybe if there's interest, we'll do an additional session on that. So it's 5 of. We've gone through a lot here. Okay, so Aaron says an additional session on the audio player would be amazing. Yeah, I mean that. I hope that you guys take from this, the basics for doing unit testing with Alexa, overview for it. There is certainly more to cover in terms of doing deep skill testing. We have links to some of those resources that are in the presentation. But this project, and you can use it as your template for actually getting started doing your own unit testing. So we hope that it's a great start for that. In these last few minutes, though, additional questions? We do plan to make video tutorials. I see that's a question. We've been doing these webinars. We've enjoyed them. I think the next step was naturally to probably go into doing some video tutorials on particular aspects. I think probably what we went through today is a good video tutorial, but we'd actually, we'd love any feedback or input on that. Okay, that is a great question, Liz. Will you please list the ID using any plugins? The environment setup is a great point. I should have covered this as part of this because I am actually really big into I like the sort of high-powered, fully featured IDEs, and I tend to try to really leverage everything that they offer. I think it's a great tool as a developer. And it's probably worthwhile for me to go through why I think that and all the great things that you can get with it. Because I do see people use and I think, wow, you could do this faster. So I'll take that as a to-do. Yeah, I see you mention Atom. So Atom can be great, but it does require a lot of configuration. One nice thing I will say is if I put together how to set up WebStorm, you'll see that there's less to it. But it's still a very worthwhile topic. Yes, VS Code is excellent. My one comment on VS Code is, to my knowledge, you can't do the multi-project thing. So I like to have somewhere between 3 and 10 projects open simultaneously, and I have not overcome that limitation with VS Code. If somebody has an answer to that, I'd love to hear it. But it's other than that limitation, I think it's a fantastic tool. No, I have a one-core brain. I just, I mean, you do the context switching. Yeah, that's a good point. I'm not sure what you meant by that comment, Liz, copy or paste from a similar project. So I did mean for this project here, or for our super simple unit test project that I was showing you, to be a template. To include in that template, actually, the project setup would probably be a really neat thing. That's something that we could certainly do. And then you could get that sort of those workspace settings right out of the box, which I think would be helpful. All right, it's been it's been an hour, so I think we'll wrap up here. I do see one more question. I meant multiple. Liz asks, you like to have multiple projects open so you can refer to earlier code you wrote. Yeah, I'm looking at other code that I wrote, and I'm also, well, I guess, we are working on multiple projects usually simultaneously because we're developing libraries that then in turn we use within other pieces. So that is why I'm accustomed to multiple projects. But yes, I hope this has been helpful. I do apologize for the technical difficulties there, but hope you guys got a lot out of this. Like I said, we'll have follow-ups on this. We'll make all this available, the video as well as the presentation materials, which will also have links to all the projects we went through. So really try to put that all out there so you have all these resources. And then in addition to that, of course, just ping us if you have any questions at all. I'll just put this slide, this final slide up here at the end. So JPKBST on Twitter, Bespoken.io. Please just talk to us if you have any questions at all. And I'm jpk@bespoken.io. That's my email, which is also easy to find. So thank you very much. Thanks for joining for this webinar.